All right, we are live.
Awesome.
So, should we give it a minute for people to join? Let's give them 1 minute. So, hi everybody. My name is Peter Fray from Platform9 Systems. I am the field CTO here at Platform9. I manage our pre-sales team as well as our customer success teams here, and that really kind of gives me an opportunity to uh, understand what our customers are looking for when they're buying, and then understand what they're looking for when they're implementing Kubernetes. And it gives me a pretty unique perspective on the industry. One of the things that comes up quite often is zero trust networking, and one of my senior solutions architects, Charlie. Charlie, why don't you introduce yourself?
Hey guys, how you doing? My name is Charlie Martinez. I'm a senior solutions architect here at Platform9. And well, just as Peter was saying as an introduction, we are going to talk about like one of the topics that has become like more relevant nowadays, which is zero trust networking. And yeah, we will go over the details, how to implement it, what we are achieving, what we're gaining, and all that good stuff, right? So go back to you, Peter. Thank you.
Awesome, yeah. So I'm real excited about this. This zero trust networking has always been like this technology that I've heard, and I never fully understood it. And then taking that zero trust networking concept and applying it to the Kubernetes world is something that I think is pretty unique and exciting. And I think a lot of our customers are going to talk about that. Can we move to the next slide here?
Sure thing. Let's move on.
So Charlie, why don't we do a quick little level set for our audience, and maybe you could tell them what is zero trust, and then what is zero trust networking on top of that.
Sure. Well, basically, what is zero trust? Zero trust is a network security approach where we consider that all networks, internal, external, are considered hostile, right? In, uh, on behalf of the company. So at that point, we need to basically understand what kind of flows of traffic is going from point A to point B and C to D, right? And if you kind of picture it, it might look something similar to what it used to be back in the day about like DMZ, right? Demilitarized versus non-demilitarized, right? But the idea here is that now we're going to translate that concept and now extend it and making sure that everything is like an insecure place. And now we need to start like allowing specific flows for every single thing that we want to communicate with on the perspective in a Kubernetes cluster, right? So that's kind of overall
So
short explanation.
yeah, Charlie, when you're thinking about implementing a zero trust network, and in the old days, I would always think, oh, there's a DMZ, demilitarized zone, that free public access. Anything can happen out there. It's the wild, wild west. And the non-DMZ is kind of a safe area. And it always was kind of a logical separation, in the world. Now, we're I don't know if that concept still applies, and people are implementing that and zero trust. But the idea of not trusting anybody in the non-DMZ network is kind of unique. What are your thoughts on that?
Yeah, definitely. Like one of the things that happens frequently is that when people start consuming Kubernetes, right? Like Kubernetes out of the box is like it's it's an open field, right? So at this point, it's like cool. I mean, I can just like deploy some Helm charts here and there, right? Or customize YAML files, and I have my application up and running. But you never really stop for a second and think about like security, right? So on that front, what we are going to be leveraging on is on Calico and the CNI, right? Which is the container network interface that we are going to be using in order to be able to provide the security level, right, to the application that we're providing to an out of the box Kubernetes cluster.
All right, let's move on to the next slide.
Sounds good. All right. So at this point, like, well, why zero trust, right? Um, One of the main problems and concerns is that when you deploy something in Kubernetes, as we stated before, it can talk to anything, right? And the problem is that if you have these kind of flows wide open and you are not like specifying how to close them, but close them not just like, hey, I want to talk to point A to point B, like basically closing everything and just allowing specific things that need to communicate with, right? So, uh, what happens if you don't have that, right? Basically, you can lead communication flows, like for example, a pod can communicate to directly to an NFS server, and may delete a file, right? Or maybe you can have like direct access to a specific switch, right? And maybe you can apply a misconfiguration access you shouldn't have access to in the first place, right? So the idea is that also by having this is that if we control what we are letting to talk, right, or surface of the surface field for having like an outage would be reduced, right? So it is really important to, especially in the microservices field, that everything needs to be declarative of what can talk to what, right? So if in case of an application get compromised, that only application or even microservices got compromised in an isolated fashion way, right? So that's kind of like why zero trust, and that's what we are gaining at this point.
So to sum it up in a word or two, is really reducing the attack surface for each and every application and isolating it. So if you did get a breach on one, it's not going to impact anything else.
That's correct. Yeah.
All right, next slide. So this, I think, is a really interesting concept, right? What kind of companies and organizations out there in the world are interested in zero trust networking? You know, we have a list of several of them here. Uh, fintech, anybody that is interested in, PCI compliance and financial transactions clearly would want to. But how does zero trust interest retailers, Charlie?
Sure. Like for example, basically most of the retails companies right now or like nowadays are like leveraging on Kubernetes and microservices and micro segmentation, right? So it is like really critical for them. Like for example, like their card like the card application, right, like doesn't get compromised, or the card application only talks to a specific parts of the backend application, right? So that like having that you can reduce again the surface of having your an specific application, in this case for example a shop card, to don't be compromised, right? Or like adding or removing or even like editing um, the the list of items in the list, or by changing reducing the price or whatever, right? If you have like a source path that shouldn't be a low and is a low, and they can exploit that part. So that is just one of the many examples for each of the different kind of companies or that are in the market that they might be interested in picking up, like of zero trust.
Yeah, excellent. Does if you had to look at carriers or healthcare, power infrastructure, that's pretty interesting. Supply chain vendors, that sort of stuff. Who would be the most interested in zero trust networking from your perspective?
I mean, I don't, I don't want to just say like everybody should be like worry about them, right? But I think that every single one that is listening this slide right now, at least should be kind of paying attention to this concept, right? And just to mention why, I'm not saying like one is more important than the other, but like imagine like for example like a power infra provider, right? Like if there is a communication flow that shouldn't be happening, and they are trying to exploit like the gate mechanism on a dam, like that could be like pretty bad, right? So I think that everybody like should be kind of looking and paying attention to this concept.
Cool. All right, next slide.
Sure. So
Yeah, yeah. Go ahead, jump in.
okay. So well, as you may know right now, and due to the given what's kind of going on, with situation with Ukraine, right, and different accompanying war tensions, there is like these constant concerns about like rogue nation states hackers that for time and such approach of cybersecurity seems to be especially fitting right now. So basically, and again, like at the end, we are just kind of talking about uh, be able to identify sources that are of our trust, right? So this can be applied at multiple levels. It could be applied at geographical locations, right? It could be internally only. It could be like you name it, right? So the thing is that by closing um, this kind, like the communications in a proper way, right? You can you can save like ton of time, like trying avoiding an outage in your company, right? So and just as a better example right now, as we discussed, the tensions that are currently happening, it has led into multiple hacker attacks, right? So yeah, that is an interesting point to put a lot of attention, right, on zero trust.
Yeah, I think there's been a lot of companies out there that
Oops,
probably
sorry.
it's okay. You can move forward. That probably had network outages or application outages or different things like that to uh, that resulted that could have been avoided, I would say, if they had zero trust networking. A breach may have happened, but if you can isolate it to one app or one microservice or one component, right, then that surface area is greatly reduced, and maybe then none of the private data gets lost. You read about it all the time. So I think this has got vast appeal to a lot of different companies. So let's get technical, Charlie. Let's go in. Let's talk about how we've implemented this zero trust networking inside of Kubernetes uh, with Platform 9 Systems managed Kubernetes offering.
Sounds good. Thank you, Peter. So right now, people, what you're like looking at right now is just like uh, 10 feet architecture diagram, right, of how Platform 9 uh, managed Kubernetes is kind of layout, right. On your right hand, you're gonna see what is like our control plane in the shape of software as a service, right. You're gonna see like different components around where that this um, software as a service interact with, right. So on the left side of things, you want to see what is kind of the the typical architecture, right? Which you will have like three master nodes, two or more worker nodes, along with, yeah, your kube proxy. You have some applications deployed over there. You will have now the main topic of this um, webinar is Calico CNI and how we interact with it, right? So um, I'm going to, if you have anything on your side, Peter, I will move to the next slide.
Go for it.
All right. So probably as we just mentioned before, in an out-of-the-box Kubernetes cluster, and this can be like also in a Platform 9 one, you deploy it, and actually pod-to-pod communication is allowed by default, right? It can cross two worker nodes, and that's perfectly fine, right? But what happens when you want to start like adding like some security and some control of it? So that's where our next slide that we're going to start like kind of talking about here, and this is where Calico comes into play, right? Calico by itself helps us to implement a cluster-wide default denied network policy in order to make the first step ahead in order to adopt zero trust, right? So based on that, we're gonna go into the details of like how it crosses kube proxy, where can we see like packages being dropped and all that good stuff, right? So And as we stated before, adopting zero trust at this point is because you are considering your internal corporate network a hostile place, right? So I'm going to go to the next slide here. So and we're going to start like kind of breaking down more and more the architecture here, right? So for example, on the left side, you're gonna see the representation of a worker with some pods and applications, right? And but we have something interesting here, which we're defining like external perimeter and internal perimeter, right? We're going to talk about more on where we can apply rules internally and externally, even though that for your perspective, everything we're considering that is kind of internal and is hostile, right? So just to give a little bit more preamble here, so an internal perimeter, what is that? It's like any app-to-app communication, microservices communication, and cluster IPs, right? That's what falls under the category of internal perimeter. And for external perimeter, we are talking about node port, load balancer, access to the interfaces, and what I mean interfaces, I'm talking about this one right here, right? BGP and MetalLB, right? So now for when we're working with network policies, we need to be explicit, right? For both kind of flows, ingress and egress communication, right? So in order our zero trust doesn't bite us in unexpected ways, all right? So let's continue moving on. So now the first step that we're gonna do here is that we are going to seal up all application communications, right? So on the left side, right, again, is the representation of worker node with some pods running on a specific namespaces, right? We also have the external perimeter defined over there, right? And we are going to explain on the right hand side of things the policy, the first policy that we're going to apply, right? And just if there are like any questions of where can we get like these policies or this, there is already a document publicly available for everybody, so you can kind of download and go and try like this step by step, right? So that being said, let's probably go and talk a little bit of what it is defining the manifest right here. So by default, we in Calico we have like this construct called or CRDs, which is called global network policies and network policies, right? But in this case, we're going to be applying a global one. Now we will have a namespace selector, right, which help us to define a specific list of namespaces that we want to avoid to be like this policy to be applied, right? And then we will define the type of traffic that we this policy is going to be working on, right? And then the specific rules. So probably let's go start talking at the bottom up, right? So right now what we are describing here, for example, in the allow portion, what we are saying is like, hey, for egress traffic, which is basically any pod communication from inside to outside, right? We are going to be allowing protocol UDP to the select to with a destination of select with the selector which is our QBNS, right, and port 53. With this we are allowing DNS communication to happen uh, in an egress way, right? So that is the only thing that we are allowing. Everything else, every single ingress communication flow is being dropped at this point, right? And then based on what we just described here, the rule is not going to be applied, okay, to the following namespaces here: Platform9 system, PF9 operators, and everyone and every single one that you see here, right? So at that point, we, if now looking back again to the example here, right now we are just like closing communications, right, for pods that are within the namespace called YYC, right? So and this is just kind of a small summary here. Like the above global network policy is enabling communications among all pods in all namespaces, excluding some namespaces, and allowing egress traffic for port 53 across all namespaces, right? So uh, probably was kind of a little bit of a twist here, but they that's kind of what is basically doing this first policy, right? And again, a global network policy applies cluster wide, so there is nothing that is applied to a specific namespace. It applies to the cluster wide, unless that you have filters here, as we do. All right. So let's continue moving on. All right. So now let's talk about internal perimeter and egress and ingress for pods, right? So now that we have like everything closed down in our at the application level, right? We need to start creating other sort of network policies, right? These network policies are going to allow or the communication of our application to happen, right? So for example, right now we are and sorry, with this we can be as granular as we want, right? But right now we are just going to talk about uh, be kind of a little bit relaxed with the policies, right? So at least at this point, for example, we can see that we have this network policy called allow box egress, right? So which is making mention of the egress traffic, right, for any of our box pods, right? So how does I basically just of traffic is Egress, is anywhere, right? And then this policy is going to apply only for pods that has been run equals as access, right? And where this policy applies in the YYC namespace, right? So in this case, this policy is being applied to these pods, right, for egress traffic. And then if we continue looking to the right, we have a second one, right, that is for the Nginx ingress, right, in which in this one, what we're saying is like, hey, this type of traffic is going to be ingress one, right, and the ingress action is going to be allowed only if it comes from uh, from something that has the following label, right? So at that point, we are able that our BCBox policy, BCBox pod is able to talk to the Nginx one, right? So at that point, we are able to, from one side, we are specifically describing egress traffic, and the other one, we are describing how the ingress should be flowing, right? So one thing to notice, we're just talking about internal perimeter. We have external perimeter here, but hey, we have no rules here yet. All right. So we're gonna talk later about that in a second. So let's continue moving on. So now external perimeter, right? The external perimeter, right? You can also, well, by default, again, it is like kind of naked. It has nothing that is protecting it, right? So you can define global network policies, right, in order to be applied to the interfaces of our workers, right? So at this point, for example, how do we create it, right? We need um, we need to leverage on labels and selectors one more time, right? But now we need to also create a new CRD, which is a host endpoint object, right? But let's probably talk first about like the global network policy that we're creating. This one looks a little bit different versus the other one, right? Do you remember that we have one which is closing everything, but in that previous one we didn't set up any order number, but now we have an order number here. So let's probably start talking and describing that. So global network policies are being, if you have multiple ones, they are going to be applied in an ascendance order, right? The first policy that is going to be applied is going to be the smallest number, and then continue going with the bigger numbers. And if you do not have specified an order number there, right, it is going to be associated to the infinite. So that is going to be the last policy that is going to be evaluated. So in this point, right, the first thing that we are going to do is that we are going to allow outbound external traffic, right? So we will have a selector which can be in this syntax, which has not for external ingress, right? And then the action that is going to be doing in the egress traffic. So it is allowed. That is the first part. So right now with this policy, we're describing egress traffic from an interface to the outside. Now, on the second leg of this, we have a different order number, right, which is going to be applied later than this one, right? And we have something here like pre-DNAT and apply and forward. So these specific parts here are related with how Kubernetes handles the natting, right? And one of the cool things is that Calico can apply rules before any destination NAT happens in the background, right? So what we are doing here is like, hey, we're going to allow ingress traffic, right, from the following sources of IPs, right? And this is very important. If you do not have these rules set up and then you apply a policy that blocks down your ingresses, basically like your external interfaces here, you are going to break your cluster in pretty bad ways. So what we are allowing here is that, for example, this network here, it is the pods CIDR that we are defining. Sorry, this is not. This is the network of our workers and masters, right? And this one is the network of our pods CIDRs, right? So that that one, that kind of source, sorry, that kind of flow is allowed, and everything else is denied, right? And it is going to be applied to the label and selector that has not for external ingress, right? So now that being said, right, we are going to label our workers, right, that we want to this policy to be applied, and later, finally, in order to grab right these two rules, we are going to we're going to create this new object called host endpoint, which is basically a representation of a worker with the label that it should have, right? And then what is the interface name that it has, what is the expected IP, and what is the name of the node. In my case, when I was writing this, I wasn't using DNS names, so that's why I am seeing you're seeing here the IP of my worker, right? So, all right. So, I think there was a question. Okay, right on. Okay, so let's move on. Okay, so external perimeter, right? So at this point, for example, one of the things that we just did is like we just like open communication for known sources that should be allowed, right? Now the next part that we are going to demonstrate here is like, hey, what happens if I want to open a node port, right? By default, node port is going to be closed, right? So and on that in that case, what we are going to do now is like, okay, we are going to create a new network policy, all right, that is going to be of the type ingress. Sorry, let me just go back here. Sorry, I was like looking into two different places. So the first that we're going to get started describing here is again another global network policy, because the global network policy is going to be applied right. And now we're saying like, hey, we are going to allow TCP traffic with a destination selector, right, that has node port external ingress, which is basically the worker itself, over ports 32127, which is the node port of our interest, right? And then once this communication flow is allowed, right, at this part here, that doesn't mean that in the internal that flow is allowed. So we need to specify, right, how that flow is being seen in the kernel, right, and start creating a new ingress one, right, with a source selector.
Hey, Charlie,
Yes.
I don't know if you're using your mouse as a pointer to try to describe things, but we can't see that if you're doing that. So,
Okay.
um,
No, thank you for letting me know that. So I will like mention like what I'm describing. All right. So on the right hand side, if we look to the network policy called allow in nginx ingress, that we are going to do now is that we are going to allow the traffic that is coming over the node port to the application, right? And the basically at this point the ingress type and the source, etc., is like kind of self-explanatory at this point. But what we are sourcing as considering our source is going to be the IP, right? One of the node port itself, right? And the second one, the IP of the, or basically the block of IPs that is coming from our workers, because that's how the traffic is going to be seen. right? So at that point, let's continue and move on. All right. So one of the coolest features about Calico, right, is that Calico can encrypt traffic east-west, right, by just simply adding a specific manifest and a configuration file, right? So what exactly happens or how why we should consider this? Because at the moment that we enable this, right, WireGuard, the traffic is going to be seen differently east-west from the east-west perspective, and we need to write proper rules, right, for east-west traffic for our applications, right, in order for the communication of applications to work, right? So that being said, I'm going to move on ahead here. All right. So on the left side, right, you want to see like two workers nodes. You want to see that now on the lowest part we have WireGuard, we have Kubernetes, and we have Calico there, and we're gonna see like how proxy is connected to ETH0, and ETH0 is connected to a WireGuard Kali interface, right? So at that point, over that virtual interface, a secure tunnel is being established for east-west traffic. But now we need to create new rules, right? So what we are just doing here is that we are going to update the network policy for our application Nginx to now allow traffic coming from a different sources, right? So at the moment that we enable WireGuard, we're gonna have an IP on the segment of our pod CIDR, right? And now we need to specify those as possible sources of communication in our policy, right? Because at the moment that my pod is trying to reach this pod or this pod, the traffic is going to be seen coming from the WireGuard Kali interface, right? So which in this case could be the IP ending in 110 or 187, right? So and just the right on the right side, we just have again the base rule, which only applies to the external perimeter, right? Which we haven't done any change to that, and we the change in the application policy. So if we move on, all right. So one other use case where we need to consider editing or rules is when using MetalLB and external, and this part falls under the external perimeter, right? So now by looking into your left hand, you're gonna see like this small, and now we have MetalLB in place, and now how that communication goes, right? And how an external service has an IP coming from the MetalLB IP pool, right? So now we can just go again and check the global network policies on the right side, right? And now we need to create, or basically we need to allow them, right, or edit them, right, to have different sources, right? We will have, for example, if you look on your right side where they see the action allowed, the source, the net that is coming data slash 32, for example, in my scenario was the IP of my laptop that I was trying, from where I was trying to reach the MetalLB IP, then the destination is the MetalLP itself. So I am just allowing that specific flow, right? And for everything else that it might be like hitting or impacting, right? I am making a log uh, action, right? Which is like start logging everything in the kernel, so I can see like what's going on and what sources are trying to hit, right? Or if I am deploying a new application and I can see that the deployment, the communication is not working, and doing a rule of an action log rule can help you to identify what is the IP in order to help you to write the policy in order to have your communication working, right? At this point, again, on the cluster network policy, which is the first rule not to change. That is the base global network policy for the external perimeter, right? Continue on. All right. So I think at this point was hit almost the end of the presentation, right? So as a summary here, and maybe as you can see now, Calico help us to perform the first step forward to adopt zero trust by doing zero trust networking, which as we describe and discuss here, we just close and we saw different scenarios where you can use Calico or you can deploy applications or you can advertise applications, right? Could be MetalLB, could be port, right? And or just basic internal communication over a cluster IP, right? And then and the second part is that we also talk about how Calico helps us to enable encryption at rest for its west traffic. And lastly, and this is something that we didn't cover on the slides, but I think is worth mentioning, that Calico also provides native integration with Istio, right, in order to create more granular rules at the application level and headers, right? So that could be kind of like a second step into adopting the zero trust model, right? And not just like staying on the zero trust networking side of things, right? So at this point, if not mistaken, it's kind of the last slide
Back up,
here.
back up
Okay.
one. So
All right.
yeah. So everybody, thank you for coming and joining today. I think what a zero trust networking lesson in 36 minutes is pretty impressive. So Charlie, awesome work. What I'd like to say though is, with Platform 9, you do get a Platform 9 managed Kubernetes offering, right? And the whole zero trust networking came to Charlie because one of our customers was asking him about that. So what he did is he went off and said, let me look into that, and built a lab, built the zero trust networking stuff, and is then able to take that architecture and that description and tell our customers the proper way to do that. It is something that we do as part of our onboarding services, and it comes with the Platform 9 offering. A little bit of commercial about Platform 9, but I think it's important to see that these are some of the out of the box type things that Platform 9 can do for our customers as part of our managed service. Any thoughts there, Charlie?
Yeah, like this is probably one example of the kind of things that we work during like onboarding processes with our customers, right? I mean, just to be completely honest, like it's like a small different world with different requirements, different challenges, right? So in this case, we help in order to help like a customer like a better security posture, at least on the networking side of things, right? So this is one of the many examples that our team or the kind of things our team can help with.
Awesome. All right. Thanks again for everybody for joining. If you would like to learn more about zero trust networking, please feel free to reach out to myself or Charlie. If you'd like to learn more about Platform 9 systems and our managed Kubernetes offering, please reach out to me. My email is simple. It's peter@platform9.com. And I'd love to hear from you on any kind of use case or any kind of technology as it relates to Kubernetes and its ecosystem. Thanks, everybody.